Welcome to my 50-part series. No, I'm just kidding. I don't know if I'm definitely not gonna make that many. But we're gonna do this problem here. Okay? We've got step 1 is f of x plus h, or basically f of the distance traveled. We're inputting the first point, the first x value plus the distance of x traveled, which would get us the new x point. Just remember that this h is infinitesimally small. That's why we're taking the limit of it as it approaches 0. But that aside, we're going to get... So basically all you do is you take this and you put it into x. Wherever x is in the original function, you put x plus h there instead. And make sure to use parentheses because you will get confused if you don't, especially when you get all those pluses and minuses and stuff with polynomials. So with this function, it's rather simple. You have quantity of x plus h squared. Or I should say x plus h quantity squared. And that's the end of step 1. Step 2 is you're taking f of x plus h and you're subtracting the first y value, or f of x. And this is just simply this function right here. This function is that. So you're just going to take this whole thing, whatever this expression is, and you're going to move it here. So that becomes this value up here, x plus h quantity squared. We're gonna factor it out. I'm gonna pause it so it doesn't take as much time. Okay, I've decided not to factor it to start. I've decided to... Man, I'm almost as bad as the teacher. Oh, I'm gonna do this. Oh, I'm not gonna do this. Oh, I'm gonna do this. Oh, I'm not gonna do this. But just my brain is naturally disorganized, and so because I don't have a rigorous outline for this video, it's gonna be a little all over the place, and I'm gonna seem like I don't know what I'm talking about. For the most part, I do, but sometimes sometimes I have a little bit of well, we all do. Sometimes we just lose it. But I hope that you don't when you're working with math, because it shouldn't be as hard as it is. Okay, monologue over. So I'm going to put this x squared here. So f of x, we're just writing that, becomes over here x squared. And I'm putting it in parentheses. Why? Because this negative, you can think of this as -1 times this quantity, x squared. That's your function. That's f of x right here. And so let me zoom in so that you can see it better. There we go. And so that's, it's easy in this problem because the -1, you can distribute that in, and that's just negative x the negative x squared, not negative x quantity squared, but negative x, or negative x squared. Sorry. Okay, now I'm going to FOIL it. Okay. So you've got this. So this, I just factored that out. That's what this is. And so yeah, so I've just done the factoring, and x minus x squared, and so you get x squared, and I'm going to bring this term over here, minus x squared, and you can see there's a minus x squared here and a plus x squared here, and they cancel out, and that's nice. Plus 2xh plus h squared, and you can rearrange that to look like more like a polynomial, to be h squared plus 2xh. So you've got 2 here. That's your answer to 2. And then step 3, you're taking f of x plus h minus f of x And you're taking all that, what we got in the last problem, and dividing it by h. So this part's pretty simple. Well, simple for this problem because it's only x squared. So at this point, you take x, that equals h squared plus 2xh over h. And what do you see in the top? You have a factor that you can factor out. But an easier way to do that, instead of writing it outside as a parentheses, I'm just going to take one of these out. So an h squared becomes h, and this one out, so 2xh becomes 2x. So you have, and I'm going to rearrange it to be in a nice form with the coefficient in front, equals, and this cancels out, obviously, because h over h is 1. And you get 2x plus h. And that's it. And that is what you're taking the limit of as h approaches 0. So now, do step 4. F of x plus h minus f of x. You can see why we don't do delta x, because we'd be drawing two symbols for every time we write h over h. Shoot. Remember to write your limit as h approaches 0. Step 4 of this function here. And that equals the limit as h approaches 0. So you're just going to plug in 0 for h in this expression up here. So we've got 2x plus 0, because that's our h. If h is 0, then 2x plus 0, and you get 2x. Woohoo! That is your derivative. F prime of x equals 2x. So you're like, wow, why all this work for such a little answer? But that's the nature of the formula. And it gets more and more lengthy and looks more and more complicated the more complex your original function, but it's not really that hard if you think of it all as substitution. You're just substituting x plus h into the original function for this. For this, you're just substituting the function itself, and then you just do the algebra and cancel terms out, and once everything simplifies, then you substitute 0 for h, and you get your derivative. Sometimes there's going to be a function where there is no h where all of the h's cancel out, and in that case, your derivative is just a number, or is just a number, and that's fine, because if your derivative is a straight line, then it's a straight line. Some functions are just like that.